So just to jog your memory, we've started a brand new unit. The initial bit was some terminology. We talked about scalars and vectors. We said that scalars had magnitude only. Vectors had both magnitude and direction. I did say to you, anytime I introduce a new concept to you, you will need to memorize what symbol we're going to use. Most of the symbols will make sense. We'll use capital F for force. We'll use a lowercase m for mass. Most of them will make sense, but we are going to run into situations where we don't have enough letters in the English language and we got to use some Greek letter or something else once in a while. You'll need to memorize what units we use to measure that specific thing. That's well worth doing. And you'll need to memorize whether it's a scalar or a vector. Sometimes it's a little bit easy. Speed is a scalar. Velocity is a vector. Sometimes it's a bit trickier. Distance is a scalar. Displacement is a vector. And Amber, I haven't come up with a dumb, clever way to remember that one. If you come up with something that I can use, I'll give you credit for the rest of my career, and I'll use that. We said that we show vectors with a little arrow. Although we get lazy, we don't even write the full arrow above the letter. We just do the one little pointy part. We don't even do both. You can, but we won't. And then I started talking about the difference between distance and displacement. I said distance was how far an object has traveled. Displacement is its change in position. And I did a little dance up here where I was walking back and forth to show you the differences between distances and displacements. And those of you that were away, don't panic. You'll get this. But we got to pause here. I should have also mentioned that displacement is measured in meters, and it's a vector. This next bit is to help you understand the difference between distance and displacement. I'm not actually going to ask you stuff like this on a test. I'll let you know when we hit fair game stuff, because in the future you'll hear me say, I like this question, I like this question, I like this. That's the hint that, hey, this is where we're starting with the good stuff. But this is, again, just sowing some seeds. When an object starts moving, it's useful to be able to describe an object's location. And one easy way to do that is to imagine a meter stick placed next to the object, and that meter stick will behave like an infinite number line. We'll say to the left is negative. We'll say to the right is positive. You could flip it because it's completely arbitrary, but just so that all of our stuff looks the same, we'll go with the mathematical convention of letting to the right on the x-axis be positive and to the left be negative. So example 1 says this: a little bug walks along a number line. It starts at A and walks to B. Let's draw that in. Let's draw a little arrow pointing from A to B like that. And then it turns around and walks to C. So I'm going to draw an arrow a little above there going from B to C. What distance did the bug walk? So the symbol for distance that I'm going to use is a lowercase d. I think I told you last day that's technically wrong. I should probably be using an x for the x-axis for a horizontal distance and a y for the y-axis. I just use d for distance. So here's the question. What distance did the bug walk? Well, Amber, how far did it travel from A to B? How many meters? How many meters did it travel from B to C? Be careful, you're going to have to do a little bit of math in your head. How many meters did it travel from B to C? So what's its total distance? Yes. Units, meters. Okay. What's its change in position? Or that's the fancy word for, what's its displacement? That would be d with the vector symbol over it. Well, Amber, where did we start? What number? What number did we end at? What's its displacement? What's its change in position, folks? Ryan. Okay, so you could do one of two things. Don't write this next bit down. Don't write this next bit down. You could say 6 meters left, but what's a shorter way to show left? You just said it. Write that down. Where I would take a half mark off, Amber, is if you said, don't write this next bit down, if you said negative 6 meters left, I would argue that negative left technically means what? I would argue it means right, and I would take a half off and say commit. Use one or the other. I'm going to choose to go with mathematical notation. It's less writing, and I think you can handle it. It also helps you get a better understanding of integers that were seen so strange way back in Math 8. Hey, they all figured out to turn the page without me telling them to turn the page? Oh, nope. One of you needed the hint. Sorry. I know who you are. Path 1, Path 2, and Path 3 are three different paths to get from A to B. In only one of them is the magnitude of the distance and the magnitude of the displacement the same. Which path has the same magnitude for distance and displacement? Path 1, Path 2, or Path 3? Path 2. Now, this question actually asks which one has a different magnitude. If you read carefully, along which path would your distance be different from your displacement? So path 1 and path 3, it would be different. Path 2, the magnitude would be the same. We can use arrows to represent a displacement. For example, a bike moving along a number line from a position of +4 to a position of -3, the fact that the arrowhead is on the left-hand side tells you that's where we ended up. And in fact, we'll often use a variable, x maybe, or d, I'll usually use d, to symbolize an object. And the big one is we'll use subscripts, I or f, to show initial, starting, or final, ending. So you'll often see me do that and do that. For Jazz in the back corner, who's the farthest away, Jazz, whenever I write a lowercase I, I'll always put a little curly thing on the bottom. So even if you can't see the dot on the top, you know that's not a 1. It's just a habit I've picked up so that from a distance you can, oh, that's an initial, Mr. Dewitt. Especially with my tablet, sometimes when I dot the I, the screen doesn't pick it up and I might not notice that the screen didn't pick it up. So if you're wondering why I always draw my I's like that, that's why, okay? Initial I means starting out. Final F means where you ended up. Example 4 says, draw an arrow showing an object that moves from the -4 position to the +5 position. I'm going to put a little dot right there. I'm going to label that initial. I'm going to put a little dot right there. I'm going to label that final. And then I'll draw on the arrow. You can freehand or you can use a ruler. I don't care. Cameron, what's this object's distance? Yeah. D equals 9, and then units, meters. What's this object's displacement, Cameron? Where did we start? Where did we end up? What's our change in position? I'll give you a hint. You could probably say the same thing that you said a few minutes ago. Yeah, now if we wanted to be fussy, you could say +9 to indicate to the right. In math, it's understood that if you don't put a plus sign in front of a number, there is an invisible plus sign there. I've made a little sloppy notation mistake. I'm hoping that Kylie is going to point it out. I did that on purpose. What's the sloppy notation mistake I made? I won't take marks off if you forget a vector symbol. That will take care of itself. Peter, later on this year, not right away, probably after Christmas, when we look at momentum and car crashes, their direction is so important, and when there's collisions, there's so many changes in direction. You're going to see I suddenly get very meticulous in my vector notation, and Juliana, the kids that aren't careful, often they'll miss out on an implied negative, and they'll lose the mark because they're not being careful. So I won't take marks off if you forget a vector symbol. It'll happen if you're not careful when we get to the more vectory stuff. But I gotta be honest, this year, positive is going to be forwards, negative is going to be backwards. Up is going to be positive, down is going to be negative. We're going to keep it fairly straightforward. So we're going to be fairly casual with our vector notation in Physics 11. If you talk to any of your friends in Physics 12, or if you take Physics 12 in the second semester, there we're going to be much more meticulous because we're going to be starting to go two-dimensional, which means you really got to pay attention to which way things are moving. Draw an arrow showing an object that moves from +7 to -2. Okay. There's initial. There's final. Matt, what's this object's distance? Nope. What's this object's distance? Not -9. Yeah, 9. What's this object's displacement, Matt? Nope. What's this object's displacement, folks? Darn right, it's -9. It's to the left. You said both answers backwards. See the difference though, Matt, right? -9, displacement, direction to the left. 9, magnitude only. Who cares what direction? Draw an arrow showing an object that moves from the 7 position, okay, to the -2 position, okay. So that's the first pathway. But then there's another trip to the +3 position. I'm going to put a little dot right here, dot at 3, and go like that. I guess, Derek, my initial would be here, my final would be here, and that -2 is neither initial nor final, it's just a stopover point. Ooh! David, what's this object's distance? Well, how long is the first trip? How long is the second trip? So, by the way, David counted, and you know what? Honestly, I probably would have counted because it's pretty small. But the other thing you could have done to figure out that 5 is you could have gone 3 minus -2, 5. Ooh, what's this object's displacement? Where did we start? Where do we end up? What's our displacement? Yes. Question back there? We're good? C says, draw an arrow showing an object moving from 4 to -3 back to 4. Okay. 4 to -3. Back to 4. And I guess there's my initial, there's my final. Carter, what's this object's distance? You count it. Ready? 4 and 3. Twice would be, yeah. What's this object's displacement as a number exactly? Yeah, you. Where did we start? Where do we finish? What's our change in position as a number exact? What? Yes. Is that helping you figure out the difference between distance and displacement? Okay. Where it's really going to become a bit more important is when we start looking at projectile motion, throwing objects into the air or dropping them from cliffs. So this says a ball is thrown straight up into the air. It rises 11 meters up, and it comes straight back and ends up where it started from at its origin point. What distance did the ball travel in total? Yep, 22 meters. Carter, what's its displacement if it ended up back where it started from? Which is going to be a little tricky for us to sometimes wrap our brain around, because people are going to say, well, didn't the ball go somewhere? Not if we're talking displacement. I'm not going to ask you questions like that on the test. That was just to help you get a feel for the difference between distance and displacement, and also hopefully help you kind of memorize which one's the scalar and which one's the vector, because I don't have a dumb, stupid way for you to remember which is which. We want to talk about speed versus velocity. Average speed is triangle D over triangle T. Except nobody reads that as triangle T over triangle D, or triangle D over triangle T. When I see a triangle in science, especially in physics, what is that letter as a Greek letter? It starts with letter D.
Delta.
Okay, it's a delta. Thank you, thank you. But that's not how we're going to read it either. If you look at your green formula sheet on the front page, the very first thing that I wrote, Hollis, much like sometimes an actor has a catchphrase or a line, you're going to find when there's a hugely important concept when I'm doing a topic or a unit, I'll pick one student and that's going to be their line. Hollis, this is going to be your line. On the top of your green formula sheet, it says delta equals two words, starts with letter C, starts with letter I. I'm going to from now on say change in, what's change in anything according to your green formula sheet?
Final minus initial.
Say that again. What's change in anything?
Minus final.
You're also going to find it's a weird tongue twister. You're going to sometimes say, and we're not going to make fun of it. Everyone's going to do that as well. What's change in anything? Carefully.
Minus.
I know.
Final minus initial.
Change in anything is final minus initial. Of course, I chose to abbreviate here. Yes? That's going to be handy to have in your back pocket. Many times this year, I'll ask you to find the change in something. You know what I'm really asking you to do, Matt? Find the final something, find the initial something, and then do what with those two? Subtract. So later on this year, for example, you'll find impulse. Impulse is change in momentum. You'll find the final momentum. You'll find the initial momentum. The impulse will be subtract those two. There's all sorts of change ins that show up. So that's going to be really, really handy to kind of put in our back pocket. I put it on your formula sheet this year. In Physics 12, you'll have committed that to memory because I'll flog it to death. Certainly Hollis will have her line down pat. Will have the line down pat. Yes? Thank you, Hollis, my friend. As an equation, we would write it this way. V average. There is a symbol for average. Don't write this down. The symbol for average, look up, don't write this down. It's a horizontal line. That means average. But when I type this stuff for you and I photocopy it, the difference between that and the vector symbol is tricky to tell, especially when I shrink the font down. So my abbrev for average is just going to be AV or AVG as a subscript. We're going to use subscripts an awful lot. Hollis, what's change in anything?
Final minus initial.
So I guess this is going to be D final minus D initial all over T final minus T initial. I gotta be honest. Distance and time in particular, because they're always change-ins, to measure a distance, you have to measure two locations and see how far apart they are. You're always doing a final minus initial, whether you realize it or not. This is why I was hinting to some of you when you were counting back here, you know, you could just look at that number, and subtract. Because it's always a change in, we get a little bit sloppy. We drop the change in, and we drop the change in. Time is the same. To find time, you have to start a stopwatch, that's your initial, and stop a stopwatch, that's your final. And what the software does is it subtracts those two times and tells you, oh, that was 4.3 seconds. So we get a little bit casual here. The equation that you'll see on your formula sheet probably says this. Did I give you that on your green sheet? Can you, and this is my way of saying, all of you, can you find it so you know that it's there? Yes? Okay. What would the units be? Well, what are the units for distance? What are the units for time? So I guess the units would be meters per second. In other words, if you see a number with meters per second next to it, you know it's either a speed or a velocity. It's a speed if there's no direction, much like your future, and it's a velocity if there's a magnitude and a direction. Oh, speed, scalar or vector. Average velocity is going to look really, really similar to what we just said. It's going to be the change in displacement over the change in time, where change in anything is equal to what, Hollis?
Final minus initial.
And I could walk through exactly this same little dance, but I'm going to give you the punchline. Average velocity is displacement over time. And they're both technically change-ins, but because they're both technically change-ins, we get a little bit sloppy, a little bit casual. You want me to put that right there? And time is a scalar. We don't put the vector sign on it. Units would also still be meters per second. This would be a vector. Let's look at an example. Suppose the bug's trip mentioned in example 1 took 30 seconds. What's the bug's average speed? Well, average speed is equal to distance over time. Derek, how much time has elapsed in this question? They told me. So it's going to be over 30. Derek, can you go back to example 1 and tell me the bug's distance, please? You have to turn back. My brain is remembering 14, but I might be totally misremembering. Was it 14? That was a fluke. All right, get your calculators out. What do we get? And I get, okay, Mr. Dweck. Yes, Peter. How many sig figs? You got your calculator out, like I said several times already? Well, I told you at the beginning of class to get it out several times. And I also told you, I'll call you on it if you don't. Okay, there, called you on it. How many sig figs am I going to go to? Did we just write our unit test quest on sig figs? I'm not going to emphasize sig figs for the remainder of the year. I've tested you on it. Let's, when in doubt, 2 or 3. Usually 3. So, Peter, what will the answer be? 0.4, what? That's 2 sig figs, and that would be rounded off wrong, so thank you for playing, but no. The third sig fig is right there. See it? So 0.46 what? Loud and proud. Earlier today, my other block, I had a 0.466. I would take a half mark off if you said 0.466. We round off. We don't chop off. So 0.467, absolutely. You'd lose a half mark for this right now. Units. Okay? We're not going to go work for Verizon. What's the bug's average velocity? Well, average velocity vector is going to be displacement over time. Derek, what was the time? Still 30. Derek, can you go look at example 1? What was the displacement? I don't think so. Because that would be a boring question. I wouldn't do that for the first one. I don't think so. Displacement was not 6. Okay. So thank you, first of all, for making every silly mistake in the book, because don't do those. Okay? Read the correct question and pay attention to the signs, please. -6, which I'm pretty sure is -0.2. Double check me. Oh, if I wanted to show off and go to 3 sig figs, I could go -2.200. What's the negative telling me? On average, the bug was traveling backwards. That's what it's telling me. Oh, it's also telling me because on average the bug was traveling backwards, it ended up behind where it started from, which I think it did. So there is information packed in there. Meters per second. Where's the direction? The negative. To the left or backwards, or I've called it behind now. Next page. Today, I want to get you to dip your toe in the water of maybe the single most useful skill I'll give you. This is one that will come in handy for those that are doing chemistry and for those that are doing math. I want to try and teach you something called formula manipulation. I'm going to teach you to rewrite equations in your head. By the end of next week, my goal is that if you see this, you can glance at that and say, oh, that also means that A equals VF squared minus VI squared all over 2D. And 99% of you will get there and will get that fast. If I can build that into you, I've dropped your memorization down by about 90%, and I'm able to give you a single-page formula sheet instead of a book formula sheet. So, looking at this here, how many variables are there in that equation? You know what that means, Amber? It actually contains 3 different equations. Would you like to memorize them? No. I will show you how you can derive them. So it says, what would an equation be for displacement and for time? Since it's asking me for 2 equations, draw a little line down the middle of your page. Callie, I know this is going to bug you, but for the calculations, I'm going to chuck all the notation. I'll bring the notation back at the very end because it's just going to clutter my work. I'm going to say this says V equals D over T, and yes, I know there's vector, whatever, an average, whatever. Amber, I would like to get the D, the displacement by itself. What side of the equation is the letter D on? The left side or the right side? Okay? Until we get good, I'm just going to put a little dot above the thing I'm trying to get by itself. What side is it on, Amber? The left side is going to drop down like a domino. Kathunk. And in fact, I can kind of imagine the equal sign drop, but don't draw that. Don't, just imagine it. Kathunk. What else is on the same side as the D, Amber? What's the T doing to the D? Adding, subtracting, multiplying, or dividing? Dividing by T on the right is the same as doing what on the left? I'm going to argue, don't write this down, look up, don't write this down, look up, that this is actually the same equation. It is. Except I'm trying to get the D by itself, and in math, usually we write the thing by itself not on the right-hand side, but on the left-hand side. So instead of doing that, I'm going to say equals D. Write that down. And now I'll bring in all my vector notation, Juliana. There's my displacement, there's my velocity, and there's my average. Did I give you that equation on your green sheet? I can't remember. Did I give you D equals VT? Yeah, I did? Okay.
No.
I think I gave you the scalar version, which is just the same as the vector version, but just a different notation. Okay. Ooh, Amber, it also wants me to get time by itself. I would not use this equation, the black one, because where is the T in this equation? On the, and specifically on the, bleh! Doing math with numbers that are on the bottom are yucky. I would choose an equation that has the T on the top, like this one. Hey, folks, how would I get the T by itself? How will I move that V over? What's the V doing to the T? Adding, subtracting, multiplying, or dividing? So another equation would be the D would just drop down like a domino. I would divide the V, and then everyone look up, don't write this down, look up, don't write this down. Technically that equals T, but do you mind instead of having that equals T, I'm going to go T equals like that. And now I'll bring in my vector notation and my average. We're going to, in a couple of days, learn the 4 kinematics equations. They're the second row of your formula sheet. They're the third row, of your formula sheet, if we count the change in as the first row. They're the second equation row on your formula sheet. And my goal, Jazz, by the end of next week is that you can glance at any one of those equations and almost boredly, without even thinking, get any one letter by itself properly in your head. If I can get you to that, I've saved you a whole bunch of writing, I've saved you a whole bunch of memorizing, because each of those equations has 4 variables, which means each equation is 4 in 1. It's actually 16 total equations. You're not going to memorize them. I'm not going to give them to you. I will show you how to derive them. Way better. Oh, and that's a skill you can also find handy in your math classes. Example 7. Here it is. This is our first physics word problem. In physics, we are going to do word problems. And right now, I know many of you are thinking, ugh, word problems. Word problems in math, Taya, suck. They're contrived. Like, here's a classic math word problem. You're doing systems of equations. Children's tickets are $2.50. Adult tickets are $4. If the gate gets $1,690, how many of each ticket did you sell? For Pete's sake, you'd effing count the tickets and walk away and you'd be done. Like, what a stupid, contrived question. I have no use for those. In physics, I will always try and give you something that's at least vaguely interesting, and as we learn more, I will always try and show you, here's areas we can apply this. But one of the nice things about word problems in physics, in math, when you're doing a word problem, the big question is, well, what do I let be X? In physics, it's always going to be really obvious what they're asking you to find. Really obvious. Read along with me, Noah. It says this. A motorist travels 350 kilometers during a 6-hour period. What was his average speed in kilometers per hour and meters per second? Noah, what's this question asking me to find? I'd like you to actually use the same phrase that they gave me. What is this question asking me to find? I'm looking for a phrase that has one word that starts with an A and one word that starts with an S. It's pretty obvious. Unless you suddenly choose to make up your own words. It's pretty obvious. It's not like in math where you go, what the heck is X? Okay. I also notice there's a part A and a part B, yes? I'm big on writing stuff down mindlessly. The very first thing I would do is I would go, okay, part A. What are they asking me to find, Noah? I would write down V equals question mark. I always write down what they're asking me to find. I put a question mark next to it. Peter, have I written something down? Yes. Do I feel better? Am I more relaxed? Yes. But also, just by writing that down, by the end of the year, when you've learned a lot of physics, you'll already be narrowing it down to a specific group of equations or an area or whatever. Now what I do, Noah, I'm going to go back through the question, and I'm going to look for numbers and physics words. I haven't taught you any physics words yet, so right now you're just looking for numbers. What's the first number you run into? What are the units next to that 350? So what physics concept is that? Time? I'm going to write down D equals 350 kilometers. What's the next number we run into, Noah? What are the units next to that 6? What must that be? Now, our preferred units for distance are meters, and our preferred units for time is. But what does it want the answer A to be in, Noah, units-wise? This will work. I'm not going to do any conversions. I'm looking for an equation that's got a V, a D, and a T. Well, you've only got one equation right now, so it's kind of, well, duh. But that's the process we're going to get into. We have this. V equals D over T. I write down the equation. And now I'm going to plug in the numbers. Noah, what's D as a number exactly? What's T? What do we get? I get 58.33. Oh, I'll go 58.3 kilometers per hour. I have a habit, once I've found a final answer, I often draw a box around it. You don't have to. That's my spiking the football after a touchdown or doing a happy dance when something goes right. It's a good habit, especially those who are thinking about taking Physics 12 with me. In Physics 12, when we do rocket science, one question takes up an entire page, and you're finding something in order to find something in order to find something. And what I teach my kids is once you found the first thing, draw a box around it so you don't have to go hunting for it later on. Once you found the next thing, draw a box around it so you don't have to go hunting for it later on. It makes it way easier. So it's a good habit, but you don't have to. Okay. Jazz and Deep, what does B want me to find? No, B. Same question. I have to do a conversion. You know what I'm going to do? I'm going to write down what they gave me. 58.3 kilometers. And I'm not going to write it as a slanty fraction. Slanty fractions are evil. I'm going to write it as a complete vertical fraction. I need to change kilometers to meters. I need to change hours to seconds. Which one you want to do first? I don't care. Pick. Okay, so where's kilometers going to go in my conversion factor? On the, and meters on the top, and kilo is 10 to the 3, and that goes where the kilo isn't. If I stop there, that would be meters per hour. I want meters per second. Do you happen to remember how many seconds are in 1 hour? Since someone remembered, we can do that as a shortcut. So hours, because it was on the bottom, goes on the top. Seconds on the bottom. 1 second is 3,600, so 1 hour is 3,600 seconds. Now, some of you started typing on your calculator. That's okay, but I hope you didn't type 58.3. That would be silly. What should I type? Darn right. Why not use my answer button? It's not a rounded off answer. It's less typing. It's more accurate. And there's less chance of me making a typo. So answer button times 10 to the 3 divided by 3,600. And I get 16.2 meters per second. Wait. To go from kilometers per hour to meters per second, we're going to do that one fairly often because the preferred physics units for speed is meters per second. But cars, I want to try and give you questions that are legitimate. So we will, by far, the biggest unit conversion we'll do is kilometers per hour to meters per second, or meters per second to kilometers per hour. It looks like I times by 1,000 and divide by 3,600. You know what? I think technically to go from kilometers per hour to meters per second, I think it's just divide by 3.6, because that's really what you're doing when you times by 1,000 and divide by 3,600. What about to go from meters per second to kilometers per hour? What do you think I would do? On your green formula sheet at the bottom of the front page, why don't you add that? Because we're going to do that one so often, I'll derive that once and then I'll stick it on my formula sheet. You'll probably end up memorizing it because you get sick of looking it up, which again, Amber, is the only reason you should memorize something, but stick that on your green sheet. And if there's somebody who's normally at your lab table, when they're here next, can you remind them to add that to their green sheet, please? Thank you. Yeah, it's divide by 3.6 and times by 3.6. Example 8, I like example 8, I like example 8, I like example 8. Example 8 is a nice question. Here is where we're doing stuff that I think is fair game. Says this, the speed of sound is 330 meters per second. Sheldon is shouting at the base of a steep mountain. If the mountain is 320 meters away, how long will it take before Sheldon hears his echo? Have any of you ever been somewhere where there was a really nice echo with a nice delay of several seconds so you could yell and then hear it come back? Yeah? Okay. So, by the way, this you can also use to figure out how far away the cliff that you're bouncing the sound off is. And I'll show you how to do that in a second. But first of all, Taya, what's this question asking me to find? Which physics concept is it asking me to find? Distance, speed, or time? How long is a tricky phrase in English because how long is the football field? You all understand that means distance. How long was the movie? You all automatically understand I mean time. So you have to read from the context of the question. But I agree with this time, I think it's asking me to find that. So Taya, I'm going to read through this question looking for numbers and physics words. The first thing I see is that 330. What is that? What are the units next to that 330? So what is it a measure of? What must it be a measure of? Is it a distance? Do I measure distance in meters per second? No. What is it a measure of? Now, there was a bit of a hint right there, but I'm going to argue, even if I hadn't given you that word, if you see meters per second, it's a speed. You do want to commit units to memory. As someone who tells you I hate memorizing stuff, if I tell you something is worth memorizing, it's really worth memorizing units. Okay? So, Taya, I'm going to write this. What's the next number you see, Taya? 420? What are the units next to that 420? What's it a measure of? Yes. And I did a quick check. My units are nice. They're meters and they're seconds. If one of these had been kilometers, I'd have to do a conversion. Taya, I'm looking for an equation that's got a T, a V, and a D in it. There is one. You know what? It's this one. D equals VT. Taya, get the T by itself. How will I move the V over? Yep. T is going to be D over V. It's going to be 420 divided by 330, which is what? And of course, you're all typing in on your calculator and following along. If you're not, and I catch you, I'll damage your self-esteem. Did you get 1.27 and the 27 looks like it's repeating? I don't think that's a 3 on the end. I think it's 27272, but my calculator rounded off. Is that what you got? Why is that wrong? Because it is wrong. For a candy, can anybody tell me why this is the wrong answer? Is that a... I'll give you a hint. Echo, 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 echo. That's your hint. What? I don't know. You said we have to have it. We're going to use nouns and not pronouns, and that'll help me. Adam.
Is that the time it takes for the sound to go 20 minutes?
So, carry on.
So you need to double that.
Okay. Echoes go there and back. So, I'm going to write 1.27 repeating because it's not my final answer. I'm going to round off. And I'm going to say times 2. If you want to, in your notes, you can make a little note there and back. This will be the only situation that we have to do that, but I'm fussy. Let's do it properly. Echoes are cool, and we can already do some nice stuff there. So I'm going to go answer button times 2. Taya, what's the correct answer to 3 sig figs? I was going to snap. 2.55, we round off properly. Yes? Units, it's a time. What do I measure time in? Yep. Okay. By the way, if you ever are doing an echo and you time how long it takes to go back, to get back to you, divide the time by 2. Times it by the speed of sound, 330, that tells you how far away the cliff is. Or whatever you're bouncing off. So it's kind of nice. I think it adds to the experience if you know how far away the object you're bouncing the sound off is. Good stretch. I know I've been talking a long time. I'm going slow to really help you wrap your brain around this because I'm throwing a lot at you. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in A, kilometers, B, meters? Sean, what's this question asking me to find? Distance, speed, or time? Distance, speed, or time? Distance. Why is this question yucky? Look at this question. Why is this, ugh? You see it? The units don't match. Here I have meters per second. Here I have hours. I'm going to have to do some kind of a conversion. First thing I think I would do, Sean, is I would go, Sean, I could either change this 18 to kilometers per hour, and then with hours I will get kilometers as an answer. Or I could change this to seconds, get an answer in meters, Change it to, you know what? I think I'm going to convert this to kilometers per hour. So what did you tell me they're asking me to find? You were right. That's the units. What physics concept did you tell me they were asking me to find? Help me out. D equals question mark. Sean, what's that 18? What are the units next to that 18? Or, as we like to say, meters per second. What is that a measure of, folks? Time? Okay, so I have speed equals 18 meters per second, and I don't like the units. I'm going to do a conversion. Is it something to do with a 3.6? Do I times by 3.6 or divide by 3.6 to go to kilometers per hour? It's on your green sheet now. Is it times by 3.6? So, Sean, on my calculator, I'll go 18 times 3.6, 64.8 kilometers per hour. What's that 2.5, Sean? What are the units next to that 2.5? So, we have three physics concepts: distance, speed, and time. Huh? Good. Do my units all match now? Kilometers per hour and hours? Say yes. Sean, I'm looking for an equation that has a D, a V, and a T in it. Well, you know what? It's this one here. D equals VT. So it's going to be 64.8 times 2.5, which is what? I might be able to do that in my head. Maybe I can. 64.8 times 2 is going to be 128 plus 1.6 is going to be 129.6. Remember that. That's going to be half of that. 129.6 plus 32, 159, 161 point. Oh boy, now I'm losing it. 162?
Yes.
Okay. That was partly a guess. Mostly there, but partly a guess. Units, Sean? Yep. Good. Jazz, what's B want me to do? Convert it to what? How good are we? 162 kilometers. How many meters is that? How many meters in 1 kilometer? As a number? 1,000? How many meters in 2 kilometers? How many meters in 162 kilometers? If you're comfortable just saying, hey, that's 162,000, I'm good with that. Or you can build the full chain if you want to. But if you're at a stage now where you can take some shortcuts, yeah. We're going to do some thought puzzles. What I'm going to ask you to do is I'm going to ask you to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting so Mr. Duke will make fun of me if I don't vote. Mr. Duke will make fun of me if you don't vote. So here's the first question. It says this. True or false? An object can have a positive distance while having a displacement equaling 0. You're not going to blurt out an answer. You're going to ponder this yourself. True or false? An object can have a positive distance while having a displacement equaling 0. Who says, Mr. Dewitt, that's true? I think that's true. 1, 2, 3, 4, 5, 6, 7, 8. Oh, hang on, keep them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Who says, no, Mr. Dewitt, I think that's false? 1. Well, see, here's your other option. Who didn't vote?
Okay, then I vote false.
You have to pick. Who didn't vote? A couple of you guys didn't vote. Did you get both of you vote?
Sean.
I didn't think Sean voted.
Sean, I voted. I vote false.
Okay.
You're wrong.
Convince me.
If you're on a sphere.
Okay, here. Sorry, go ahead.
If you're on a sphere and you keep walking.
Nah, I don't even go that high tech. And we're staying one-dimensional here. Sphere would be three-dimensional. The physics is very different for what I'm teaching you. For the physics that I'm teaching you, for the math to work, Earth is flat. Even though it's not. Yes?
We already did a thing like this.
Convince me.
A few pages back. we did-
Could you make up one of your own that was very, very nice and simple?
Well, if we walk in a circle,
Don't need to go in a circle.
okay?
You're way overcomplicating this. Are you ready? I'll cue you. 1 step forward, comma.
One step back.
That would be 2 steps. If each step was a meter, 2 meters. 0 displacement. Yes? So, true. You can't have a positive distance, 2, and a displacement equaling 0. Okay, next question. True or false? An object can have a positive distance while having a negative displacement. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Okay? An object can have a positive distance while having a negative displacement. Who says, Mr. Duick, I think this is true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who says this is false? 2. Convince me. Convince me. Gershon, convince me. You voted false? Sorry, I did it again. I'm sorry. Gertej, I'm sorry. Totally butchered your name again. I will remember. Sorry.
They just yell it out.
Gertej, convince me. I'm going to give you a hint. Can you give me a way that I could have a positive distance but have a negative displacement? Anyone?
1 step forward, 2 steps back.
Even easier. How about just, what's your distance? 2? Because it's a scalar. What's your displacement if it's back? -2. Positive distance, negative displacement. Okay. An object can have 0 distance while having a positive displacement. An object can have 0 distance and also have a positive displacement. Who says, Mr. Duick, I think that's true? True. Is that a vote? Or you're just adjusting hair number 97? Okay. True? No one. Who says false? Convince me. You're correct. Convince me. Yeah, Adam.
In order to have those, you can move.
Okay. So, we can say something like this. To have, my abbrev for positive is a plus VE displacement. We would need to move. But as soon as you move, is your distance possibly 0? Nope, because you've taken a step. One of my favorite comics is called Foxtrot. The author, Bill Ammond, actually has a physics degree. And while he was in university in his physics classes, he was doodling a lot. And his friend said, you know, those are pretty funny. You could probably make a living as a comic artist. And so the Foxtrot family, there's Peter, the older brother, and then there's young Jason, the young nerd. Of course, I identify with Jason. And today they're playing football. It says this: Jason is giving Peter a football play to run. Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards. Then turn right and go 25 yards. Then turn right again and go 30 yards. Then turn right and go 30 yards. Then turn left and go 10 yards. Then turn left and go 15 yards. Then turn left and go 20 yards. Then turn left and go 50 yards, and I'll hit you with the ball. Peter thinks for a while. Won't I be right back where I started? Jason says, I can't throw it very far. So here's the first question. What distance will Peter run in order to complete this play? Well, D equals, let's see, 40 yards downfield, and then 20, and then 25, and then 30, and then another 30, and then a 10, and then a 15, and then a 20, and then a 50. I think I got them all, which is what? I can do this in my head. 40 and 20 is 60, 25, 85, 115, 145, 155, 170, 170 plus 70. Is it 240? Double check.
Yes.
Is it? Yeah. I'm not seeing much typing in that back corner there. That back corner can expect to be called out next time if I don't see more typing in that back corner there. This is how you stay following in class. Oh, if Peter ends up back where he starts from, what's his displacement? I won't do it today, but I did once take some students out and we ran this play, and you do end up back where you started from. The physics is correct. I had to make sure of that. So you do end up back where you started from. Okay? I have talked an awful lot. There is still 10 minutes left. Tomorrow, we're going to be doing a short mini lab, and then the rest of the class will be yours to work on the homework. So this is technically due Monday. The homework is every question. I did attach the answers on the very last page on the very end. There are answers, so you can check your answers. Okay? Hopefully that helped a little bit understand the difference between distance and displacement, and then how we calculate velocity or speed and time and distance or displacement. Let me pause the video and then someone asked a question. But pause.